Good morning, grade 8. Wish you are all fine and great. Here is Mrs. Mai Kamal from Hussam International School. Let's start our math session for today. Okay, extended to our previous lesson about handling data, today you are going to have a new lesson, and our new lesson is about lines of best fit. Lines of best fit, and this is chapter 2, lesson 9, chapter 9, lesson 2, lines of best fit. Okay, today we are going to talk about how to create a line out of the scatter plot, So let's have a quick check about the previous lesson. Determine whether the association for each scatter plot below shows a positive, negative, or no association. First graph here, as I told you before, if I have the scatter plot in that way, so this is positive. And if is it positive, it means that if x increases, y will be increased as well. And regarding to question number 2, as you see here, this is a negative scatter plot or negative association, which means that if x is increased, y will be decreased. This is regarding to positive and negative association. Let's see question number 3. The scatter plot shows the average price of gas at a gas station at the week's progress. Does the price of gas increase or decrease? As here we have a positive association, so the price will be increased. X increases, Y will be increased as well. So this is guys how we can read any scatter plot, or why this is what are the benefits of if you ask me what are the benefits of the scatter plot. So this is the benefits of the scatter plot, so we can get out any data we need or any information we need from the scatter plot. So let's see what we're going to have today. Today what we will learn to use a line of best fit to predict, right, and use an equation for a line of best fit. And we are going to use the equation of the slope that we had before, the equation of the slope. Okay, let's see. This is the first question. Refer to the information in the table about the cost of cookies. Construct a scatter plot using the data, then draw and assess a line that seems to best represent the data. This is the data between the years, two quantities. Here I have two quantities. The first quantity is the years since 2000. I have 2001, 2, 3, 4, 5 till 9 till 2009, and I have the average cost for each year. I need to draw the scatter plot as we learned yesterday. We are going to plot x and y, x and y, x and y. We have x as the years and y as the cost of in each year. So first of all, graph each of the data points, draw a line that fits the data. First of all, I'm going to draw the scatter plot. This is the line, I'm talking about the line of best fit. I'm going to choose a line that connect the points, but in the best way. That's why it's called the line of best fit. How can I know that the line is the best fit? Let's see. About half of the points are above the line and half of the points are below the line. This is the first thing that we can know that the line is the best fit. Judge the closeness of the data points to the line. Most of the points are close to the line, so this is the best fit line to the graph. Okay. Why should I draw a line, or what is the usage for that line? I can predict what will happen in the upcoming years. So till 2009 I have the price of $3.24. So what if I want to predict the cost in 2010 or 2011? So from that line I can predict what will happen in the upcoming years. So this is why I should use the best fit line. So how can I draw this line? After plotting the points of the scatter plot, I can just connect the points, but the points which produce the best fit line. How can I know that it's the best fit line? As you see here, as I just told you, about the half of the points will be above the line and about the half of the points will be below the line. So let's see another example here. Construct a scatter plot using the data in the table, then draw and assess a line that seems to best represent the data. This is the data here. I have average and maximum, average and maximum, average and maximum. Okay, average and maximum. So here I have average as x-axis as the horizontal line, and I have the maximum as the vertical line. So here I have 5, 10, 15, 20, 25, 30, 35, 40, and 45. This is the average values. What about the maximum values? I have 47, 50, 40, 20, 70, 77, 61, and 54. So I'm going to plot the points. I'm going to just plot the points between the average and maximum as X and Y, and just connect the line to find the best fit line, So let's see what we're going to have next. So far, we haven't found the or we haven't predict the value yet. So let's see how can we predict, or how can we use the best fit line to predict the upcoming values. Use the line of best fit to make a conjecture about the cost of cookies in 2013. So here I have the graph till 2009. I want to predict the cost of cookies in 2013. From that line, we draw the best fit line. I'm going to check in 2013 what will going to happen in 2013. Here I have till 2009. So in 2013, the Y value for 13 is about what? The Y value of 13 is about $3.35. $3.35. This is the cost. About $3.35. And then here I have the second example we had a few minutes ago. We have the scatter plot of the average and maximum years of animals. So construct a scatter plot using the data in the table. And here I want to use the line of best fit to make a conjecture about the maximum longevity for an animal with an average longevity of 33 years. 33 years. Here I have 33 years. Let's check 33 years and then go up to check the vertical line, which is refers to the maximum. So the answer will be 67, around 67. So from 33 years in the horizontal x, which is x, I'm going to look at the y value in front of the x value, which is 67 years. So here what we can do with the best line fit, we can predict what's going to happen in the upcoming years or upcoming value. Let's see what we have next. We are going to apply our second objective, which is the slope-intercept form. We are going to use the slope-intercept form, and we are going to use the y-intercept and the slope in predicting or in finding data. So let's start to read the question. The scatter plot shows the number of cellular service subscribers in the US. Write an equation in slope-intercept form for the line of best fit that's drawn and interpret the slope and y-intercept. So here I have a line, as you see here, guys, it's already drawn for you. So I just need to find the slope. First of all, I'm going to find the value of the slope. Let's remember, what is the rule of the slope? What is the rule? The main rule of the slope, m equal y2 minus y1 over x2 minus x1. So I'm going to choose any 2 points that crosses by the line, So I'm going to choose any 2 points. So they may or may not be data points. The line passes through points 3 and 150 and 9 and 275. Those are the 2 points which cross by the line. Use these points to find the slope. So I have x1, y1, x2, y2. I'm going to subtract y2 minus y1 over x2 minus x1. So here, the first step, as we usually do, is to write the rule of anything we have. So the first rule is the slope, m equal y2 minus y1 over x2 minus x1. And then I'm going to apply the points in this rule. 275 minus 150 over 9 minus 3. So here I got 20.83. This is the slope. I have. So the slope is about 20.83. This means the number of cell phone subscribers increased by about 20.83 million people per year. So this is the first step, is about the slope. Now I have the slope. Let's see what we have next. The y-intercept is 87.5 because the line of fit crosses the y-axis at about the point 0 and 87.5. This means there were about 87.5 million cell phone subscribers in 1999. So how can you get the y-intercept? As we learned before, guys, y-intercept is the point which intersect at the y-axis itself. It's intersect at y-axis itself. So the y-intercept here is 87.5. 87.5, as you see here, approximately it's 87.5 because it's between 75 and 100. As you see here in the graph, it's between 75 and 100. So the y-intercept is 87.5. 87.5. This is the y-intercept. So now I can write the equation I have of y-intercept. Y-intercept equal, or y equal mx plus b. This is the slope-intercept form. Sorry, this is the slope-intercept form. I have m, I have b. M is the slope which we got, which is 20.83, and the y-intercept, which is the point which is intersect the y-axis itself, and it's 87.5. This is b. Now I have the slope and I have the y-intercept. Now, if I have any value of x, I can easily find the value of y, as we have the slope and we have the y-intercept. Let's see how we can do this. Now I have y equal 20.83x. This is the slope we got, which is m, plus 87.5, which is the slope intercept we got from the graph. Now, if I ask you to find any value of y if x is 5, if x is 5, okay? So I can easily replace x with 5 and find y. I can easily replace x with number 5 and find y. How? Because we have the slope m and we have the y-intercept b. So how can we use the best line fit to find the y-intercept form? By using 2 points to find the slope and then find the y-intercept, and then we can predict any value in any upcoming values in x. Maybe here we have the years till 2010. I can predict the value or the cost in 2012 because now we have equation we can follow. What is the equation? It is what y equal mx plus b, and I have m and I have b. Let's see another example. Here I have the scatter plot shows the number of new foods claiming to be high in fruit. Write an equation in slope-intercept form for the line of best fit that is drawn. Now I have the line. I can find the slope. Let's find the slope first. I'm going to write the slope by myself here. M equal y2 minus y1 over x2 minus x1. Okay, I'm going to choose 2 points. The first point I have here is, just a second. I can take the point 1 and 150. This is the first point. 1 in x and 150 in y. This is the first point. And the second point, I can take 3 and 200. 3 and 200, okay? This is the 2 points I can get from the line. And guys, try to choose the easiest points, okay? Don't be confused, okay? So I'm going to apply the rule. M equal y2 is 200 minus 150 divided 3 minus 1. 3 minus 1. So here it's equal 200 minus 150 is 50 divided 2 equal 25. So here the slope is what? Is 25. Let's check our answer. The slope here, yes, is 25 plus 110. It's an easy point here. Look at the y-axis, guys. Look at the y-axis, guys. It's very easy. This is the y-intercept. It's 110. 110. So here, this is the slope-intercept form, y equal mx plus b. So now I can predict any value. Let's assume that x is 2009. What shall we do in this case? I'm going to remove x and put number 9 or 2009. So here y equal, let's apply the rule, y equal 25 multiply x, which is 9 or 2009 plus 110. And now we can find, or we can predict what the value of or the number of foods we have in 2009. So this is why, guys, we use that equations. This is why we can use that equations, and usually we use that equation in our real life problems to predict any upcoming values. Let's see what we have next. Okay, now let's see. The scatter plot shows the number of cellular service subscribers in the US. Use the equation y equal 20.83x plus 87.5 to make a conjecture about the number of cellular subscribers in 2015. Here I have till 2009. I want to predict the value in 2015. So as long as we have a slope-intercept form equation, I can find any other value, any expected other value. So let's start to apply the rule. Y equal 20 point, it's a gift for you, it's already given for you. So 20.83 multiply 15, because here in 2015, plus 87.5, 87.5, and then just find the answer. So here, the year is 16 years after, so I'm going to apply, yes, 16 here. I'm going to put 16, okay, because the year 2015 is 16 years after 1999. Here the plot, it's starting from 1999, not from 2000. So it's from 1999. So it's 16, not 15. Okay, I thought it's starting from 2000. No, it starts here from 1999. So here I'm going to put 16, not 15. So here y equals 333.28 plus 87.5. So in 2015, there will be about 420.83 million cellular subscribers in 2015. And this is my expectation. And this is how we can predict. This is how we can predict, okay? So here, let's see what we have. The scatter plot shows the number of new foods claiming to be high in fruits. Use the equation. This is the equation we have just found in the previous example. Use the equation y equal 25x plus 110 to make a conjecture about the number of new foods that will claim to be high in fruit in 2017. So it's the same, it's about 410. What you are going to do, we are going to instead or replace x with 17, okay, and then just find the value of y, which is the number of food or the fruits in 2017. Okay, guys, this is all for today. This is all we have for today. How can we apply, or how can we graph the best line to fit the graph? How can we know that it's the best line to fit the graph? By observing that the points, half of the points is above the line, and half of the points, another half of the points is below the line. This is how we can know that the line is fit the scatter plot. And then the second objective we had today is to apply the y-intercept form equation to predict any other values we need from the graph. So what is the slope-intercept form? Y equal mx plus b. What is m? How can we find m? By applying the slope rule, which is y2 minus y1 over x2 minus x1. This is the rule of the slope. How can we apply this? By choosing any two easy points from the line or from the graph, and then apply the slope rule to find the slope, which is m. And then how can we find b, which is the y-intercept? Y-intercept, as we always say, this is the point which is intersect the y-axis itself, So this is the y-intercept. I have m, I have b, so I can replace x with any number to find y. So this is how we can use the slope-intercept form to predict any values or to analyze any data we have through the given. So this is all for today, grade 8. Thank you for listening, and don't hesitate to ask me about anything. See you next session, inshallah. Bye-bye.
Nope. Yep. 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 Nope. Yep.